Hi guys, this is Miss Gray,
And this is Mrs. Uy.
and we're back to talk about Unit 4, Podcast 4.3 is all about ions.
Charged particles.
So let's get right to it
All
because
right.
we've got a lot of work to do in this podcast.
Yes, okay.
All right.
Make sure that you guys are following and writing down notes.
Yep, hit the pause button when you need to.
Yes, exactly.
So ions and atoms are not exactly the same thing. Atoms transfer electrons so that they can become more stable. And since you're already familiar with how to draw Bohr diagrams,
Yes.
then we're going to assume you know where those electrons are, right?
Yes. They are. Each atom is left with a
With a complete
complete
outer shell by moving electrons. So that's why we would transfer electrons, is to become more stable.
Yes, to complete the outer shell, and that's how atoms become stable.
Yes. So an atom is neutral, but an ion is charged. So in atoms, the number of protons evenly balances the number of electrons, right? So protons are positive,
Electrons are negative.
right? And when they're balanced, we have no charge
Yes.
overall.
Yes.
But an ion is going to carry a charge because the electrons, negative particles, are either gained or lost from the neutral atom.
Yes.
All charges work this way. Did you know that to have a charge in your iPod, we have to move electrons?
Yes.
We never move the protons, only the electrons.
Yes.
All right, so let's look at a specific example. First, we'll focus on sodium and chlorine. So let's find those on the periodic table.
All right.
Okay, so if we're going to look at sodium, I've highlighted it here. It's in the first group,
First group.
right? And so to draw a dot diagram, we represent the valence electrons for sodium as a dot.
Dot. There.
Since sodium's in the first group, that means it has one valence electron.
Yes, one dot.
Right, so in its configuration, it looks like 1s2, then 2s2,
S2.
2p6, and then in its valence shell right here, it's 3s1,
Yes.
right? So we have one dot for one valence electron. How about chlorine? If we count across from sodium all the way across here to chlorine, then
Yes.
how many steps do we go?
All right, that's one.
Let me get a new color so we can see what.
Yes.
I missed it. New color. There it is.
Okay.
Okay, so we have one,
One,
two,
two.
skip across
Yes.
all the way to here, 3,
Four,
five,
five, six, and
7. All right, so
How many dots?
7 dots, I'm guessing.
7 dots.
There it
How
is.
that?
Okay, so then what does sodium have to do to become more stable? We could give away that electron in the s orbital, and then it would look like this is the configuration for our neon,
Yes.
right? So if sodium could look like neon, it would be more stable.
Yes.
So it's going to transfer that electron.
Okay.
Now
To
look at what
Cl.
chlorine can do. Chlorine has the formation of neon, and then it has 3s2,
3s2.
3p5. So if we added one more to it, then it would be 3p6,
3p6.
which is like argon. And we know that's a stable configuration too.
Yes.
Because this total here, 6 plus 2,
6 plus 2 is 8.
right, and 8 is a stable
A stable.
configuration.
Yes.
All right, well, here's the problem though. Sodium only has 11 protons, and if we give its electron away, now it has only 10 electrons.
10 electrons.
So overall, sodium gains a positive charge,
Yes.
right? Because the electron left, now we have an imbalance,
Mm-hmm.
because 10 taken away from 11 is
so
a plus 1.
protons, yes, plus 1.
Right, and then chlorine has 17 protons.
And now it has
Now we added one more electron.
18 electrons.
All right, so we are doing 17 and a negative 18
Yes.
is a negative 1.
Negative 1. So
And now
that's why
I
it has negative charge.
didn't put these numbers here, but a plus means plus 1,
Okay.
and a minus means
Minus
minus.
minus 1.
Yeah, we don't usually write in the numbers there.
Yeah. If it's only 1, right?
Yeah, exactly. All right, let's look at 2 other elements.
Okay. Another example.
Yeah, see if I can clear my writing off of the screen so we
Erase,
don't confuse anyone.
erase.
There we go. Oops, wrong button. Here's magnesium and bromine on the periodic table.
All right.
Okay, what group is magnesium in?
It's group
Group 2.
2.
So
And then
how many dots do you want
how many
for group
dots?
2?
2 dots for Mg.
Right.
There you go.
So I'll write the shorthand configuration. We had configuration of neon,
E.
and then 3s2, and that's it.
Yes.
Okay, good. So that's not a very stable
It's
configuration.
not.
It's close to neon,
Mm-hmm.
but it's got 2 extras. And then here's bromine. It's in that 7th row.
Yes.
Remember when we did the configurations, we skipped
That's
the middle. So we
AR.
have AR, and then we go 4s2, 3d10,
3D10,
and then 4p5.
4P,
So which ones are the highest energy level? The 4s.
the 4s.
These 3s are not.
Hmm.
So those don't count as valence electrons.
Okay.
So there's a 2 and a 5 for a total of 7 dots.
Okay.
And that's what I've shown here.
Yes.
Now let's make ions out of this. Okay, the magnesium can transfer an electron to the bromine because the
Okay.
bromine has a spot for
Okay,
it.
1 dot is moved to Br.
Right, now what do we do with the other dot?
What are we going to do? Shall we just erase that, Mr. Gray?
Oh, I can't go into nowhere. Nice try.
Okay.
Let's just have another bromine.
Okay, that's a good idea.
Now we have a place for it because it would be very rare in nature to have only one atom
Yes.
of bromine. right?
Yes.
If you've got a beaker of bromine, there's a
Oh,
lot more
yeah.
than one atom.
Yeah.
Yeah. Now magnesium has given away those 2 extra electrons.
Mm-hmm.
So magnesium has
Now
12
has
protons,
12 protons
and it gave away
and
2 electrons, so that's 10,
10
electrons,
electrons.
right? So the
That's
10 minuses
2
and
plus.
2 positive, 12 positives, yeah, makes a 2 plus charge.
Okay.
Okay, let's look at bromine. 35 protons? No, yeah, 35.
35,
Oh,
yes.
calm down now, Riley.
And then 37 electrons.
No, we
No,
gained
it's-
1
It gained
extra.
only 1, yeah, 36.
Yeah, so electrons are negative, that's why I put this minus in front.
Mm-hmm.
So
That's
35 minus 36 is minus 1. So we get a minus charge. Do I have to write the 1? Or is it okay to just write a minus?
It's just write a minus, it's okay, but they have to know that there's 1 in there.
Right. It's like in algebra, when you write x,
Mm-hmm.
we really mean 1
1x.
x. We just don't write the 1.
Yes, exactly.
All right. Now we get to describe what happens when we gain one or more electrons. What
We'll
type of
have
charge?
a negative charge.
Right, because the electrons are negative. So if you have more electrons than you did before,
Yes,
it's a negative charge.
negative charge.
Okay, what if you lose your negativity?
Forge, you're going to have positive charge.
Yeah, just like a person who's being very negative, they'd be a more positive person if they got rid of
Yeah.
their negativity.
Mm-hmm.
Yes. And a positive ion has a special name,
Okay, positive ion is called
cat
cation.
ion, because cats have paws. Cats have paws,
So positive.
right. Plus you can remember to see this plus sign in the middle of this word? Positive.
Yes,
Cat ions are positive, and then the negative
it's called an
an
I-
ion.
ion.
So here's how to pronounce it. Ion. Yeah. I put that there because it's hard to keep those straight.
Yeah, exactly.
Okay, let's look at how to write an ionization equation. It's
Okay.
like a chemical equation, only now electrons are going to be written as reactants if they are gained,
Mhm.
because they're going into that substance, or as products if they're lost.
If they're lost.
So for sodium, we know we lost 1 electron. So to make the sodium ion, we have to set that electron free. Now we've separated the 2, and the electron is free to
It's
go on
free
its
to
way.
go.
For
For
chlorine,
chlorine, it's
we have to add an electron to it to make an ion.
okay.
So it's a reactant,
Okay, so
And
we have Cl.
and now
minus.
it's a negative, because we put those together to
Yes.
make the ion. Okay, what would magnesium do?
Magnesium.
I'm going to draw the dot structure again for us. Magnesium was the one with 2 dots.
2 dots.
Okay, so
So that's
is it
Mg.
easier to gain 6 electrons or give away the 2 it
Give
has?
away the 2.
Okay, so then let's show that. We'll make a 2 plus because it gave away 2 electrons.
2 electrons.
Now let's do the dot diagram for oxygen.
Oxygen is 6?
So we could either give away 6 electrons here, or we could gain 2 more.
I think 2 more is easy.
That seems like it would take less
Yes,
energy, right?
Yes.
Okay, so gaining means we're putting them as reactants. And then we have 2 extra electrons, so the charge is a 2 minus.
2 minus.
Because the electrons are negative.
Okay.
So this takes practice.
Yes. So, but they're going to do more practice in school, right, Ms. Gray?
Right, of
Inside the
course.
classroom.
Right, when we are there to help you through it.
Yes, and you can always pause, rewind when you don't get it the first time.
That's right. Okay,
Okay.
see you guys in class.
All right.